Well, good afternoon, everybody, and welcome to SIMSA's Lunch and Learn event. Today is where it's going to be about opportunities to innovate, thrive, and excel in mining. It's going to be a great event today, and so thank you for all signing in. And I see Leah's here. Great to see you made it in. Larry Jorgensen is going to be presenting, and Polson's presenting from PAMI. I got a couple of little things to take care of, and then we'll get to them. So first of all, I am sitting in Treaty 6 territory on the traditional homelands of the Métis people. Now, some of you are in Treaty 4, some of you in other places. But anyway, in any case, we're all treaty people working together. We're both beneficiaries of the treaties. It was kind of a two-way deal, folks. Anyway, one thing before I turn it over to Larry, Ian, and Leah is SIMSA's got an event on Monday on how to use the Remo platform. That's the system we're using for the mining forum. You sign into the event and try it out. You're going to find out that it really is kind of cool. We use this with Russia and Kazakhstan and here, and it worked flawlessly. It's the coolest little thing. You get to network with people, bounce around tables, talk to everybody you ever wanted to talk to. It's a whole pile of little miniature video conferences within one big one, and it works well, and it's about as close as you're ever going to get to replicating an actual conference in a virtual world. So anyway, check that out. It's on our website. So anyway, I'm done. I'm going to now turn it over to our wonderful friends at PAMI, and I see they're online, so I'm not sure which of the three of you is starting, but somebody take it away. Thank you.
All right. Well, thank you, Eric. I hope you can all see the slides. If somebody wants to just give me a nod and say that we're good to go, we're good. Okay.
Yep.
All right. Well, thank you, Eric and the team at SIMSA for this opportunity, and thank you all for giving up your lunch break. Hopefully you'll learn a little bit about PAMI today. As we often do whenever we get together, we like to have a safety share. So my share today is a reminder to be mindful of the weather. With most of us spending more time behind our computers and less time out in the real world, we're often jumping behind the wheel of our vehicles without assessing the environment like we may have done in the past. We're just glad to be able to go somewhere other than sitting in our office. So this time of year, it's especially important to take notice of conditions. The road you drove on this morning that was freshly salted or sticky enough from a recent cold snap could suddenly turn to a sheet of curling ice as temperatures rise throughout the day. So take note, test your traction, and be mindful of other vehicles on the road. Give yourself extra room and take your time. Your next team's meeting will still be there when you get to it. Okay, so let's start. So PAMI's a fee-for-service research, development, and testing organization. We operate from two locations, Humboldt, Saskatchewan, which is where I am today, and also in Portage la Prairie, Manitoba. We have a highly skilled technical team of professional engineers, scientists, agrologists, technologists, and others who are passionate about machinery, innovation, and providing value to clients in mining, transportation, and of course, agriculture. PAMI offers machinery and process problem solving across a broad range of industries. PAMI's work directly with mining companies as well as companies supplying machinery to the mines. We love challenges. Clients partner with us to be an extension of their R&D team, be an independent third-party validator of their product, provide additional support to product development and design teams during peak workload periods, and be a one-stop shop to design, build, and test for entrepreneurs. The PAMI approach is different than most. Our scientific research approach, coupled with our hands-on lab and in-field testing, ensures practical solutions to real-world problems. We employ scientists, engineers, fabricators, electronics specialists, and more. We provide the complete solution from concept to completion. We provide creative engineering and design services that are governed by a disciplined, evidence-based approach. This approach has been proven over 46 years we've been in business. PAMI's recently undergone a transformation, evolving and focusing on three strategic industries: mining, transportation, and of course, agriculture. Our strategic plan guiding us over the next several years is focused on 5 themes: establish and be a center of operational excellence, maintain revenue skill diversity, be the recognized voice of agriculture, strengthen relationships with customers to enable stronger revenue base, and grow agriculture revenue. These strategic directions will ensure PAMI will remain a vibrant, flexible, highly capable service provider for industries in Saskatchewan and Manitoba well into the future. With a new strategic plan in place, PAMI's reorganized our people with a goal in mind to maximize the value to our clients. Our business development team currently consists of 3 experienced professional engineers who work with clients to define the scope and deliverables and secure projects. The BD team continually validates the needs of clients to ensure PAMI is offering relevant skills and assets to serve clients efficiently. We are the voice of the customer to the rest of our organization. The business enablement team is our back office, so HR, accounting, and IT. This team monitors and reports on performance of the organization. When you become a client, you'll work directly with our operations team. The operations team is comprised of a dedicated project management team, currently of about 5 people, and a technical service team, which is about 25 people and grows up and down as needed. The ops team are the doers. They create value for clients through disciplined project management and project execution. When you become a client of PAMI, our operations team works collaboratively with your team to deliver the project. Project managers ensure the technical services team have the resources they need to manage, track, and report on progress to the rest of the organization and back to the client. The team consists of mechanical and agricultural engineers and technologists with strong machinery design experience. As well, PAMI has engineers and technologists with backgrounds in electronics, automation, and controls to take care of controlling the machinery and integrating machinery with other systems where required. And where machinery or products are used in agriculture, the team has agrology expertise to continue our long-standing tradition of supporting our agriculture industry. As an example of where the experience of an agrologist could be beneficial to companies in the mining, oil, and gas industries could be site reclamation and remediation projects. We know what it takes to grow things in real field conditions and the machinery required to make it happen. As the name implies, PAMI's passion is machinery. Improving existing machinery, making machinery work better, faster, longer, easier to build and repair. These are key skills that PAMI staff have developed over 46 years. And the wide variety of machinery we work on gives us a broad skill base applicable to many industries. Mining, transportation, agriculture. These industries all have machines that exist to serve a purpose, perform a task, improve safety, or automate a process that could be done manually. It's not uncommon for PAMI to reach into our bag of agricultural machinery experience and find a solution that could be adapted to an on-road vehicle or machine or vehicle used in mining. That is how we are different. Our experiences from all industries help to put forward ideas that might never have been thought of before by teams without access to our broad experience base. Applied research is a term you've probably heard that means something different to everyone. To me, applied research means applicable to real life. While PAMI engineers have scientific backgrounds and are able to dream up extravagant solutions the same as everyone else, we know that clients are looking for real solutions they can apply to their own problems today. PAMI teams are always asking, how can this new idea actually be implemented? And can we really do this every step of the way? We all have this continuous failure mode and effects analysis process that goes on in our heads. In our personal relationships with our spouses and families, that can be problematic and seen as, you never think my ideas are good. But in our relationship with our clients, we are driven to achieve a successful end result. The what if questions PAMI will ask are incredibly important to ensure that ideas are getting that proper reality check and will actually lead to a solution that can be practically implemented. Real life, real tests, real benefits. That's what PAMI strives for on behalf of our clients. If it was easy, somebody else would be doing it. This quote sums up why clients come to PAMI. Often our clients have reached a point where they might have a need for a solution to a problem, but are finding there are no off-the-shelf or proven solutions available from their usual vendors. They come to PAMI with an idea or perhaps a wish list. PAMI works with the client to turn the wish list into a practical statement of requirements. From there, PAMI can research the issue, identify possible solutions, and propose a plan to bring the client's wish list to reality. Next, PAMI will use appropriate tools from our toolbox to design, build, test, prove, and improve a solution that will have a very high probability of success when implemented by the client. And from the client's perspective, all of this can be done offline, off-site if necessary, avoiding disruption to the client's facility during the test and evaluation phase. And best of all, the final design belongs to the client. Drawings, prototypes, test data. If the client wants it and can use it, it's theirs. PAMI does not retain any IP. This is an example of a fatigue or durability test using our MTS Flex test system at Portage la Prairie. The drive file for these types of tests can be from an SAE, ISO, or other standard, or can be based on real-world data collected from strain gauges and accelerometers on an actual vehicle or machine. A major advantage to working with PAMI is the ability to test and prove solutions in-house. Within PAMI facilities in Humboldt and Portage la Prairie, PAMI can conduct head-to-head performance testing, in-field product validation and verification, durability and fatigue testing, safety compliance testing, material handling, flow loss analysis, protective structure testing, i.e. ROPS and FOPS, hydraulic cylinder performance testing. And on the transportation side, PAMI has tools and facilities for brake performance testing, seat and seatbelt anchorage testing, rear impact guard testing, tilt rollover stability testing, engine performance measurement, alternative fuel performance and emissions analysis, data collection, vibration, accelerated life testing. And we also have 2 climate chambers, one large enough to fit a highway motor coach with a nominal operating range of -40°C to +40°C. And we also have a 20% grade brake test slope. These tools and facilities provide an added dimension that is unique within the engineer, design, build landscape and allows our project teams to achieve results that have a very high probability of success with our clients. In fact, this statement from one of our clients sums it up pretty well. As mentioned in the beginning, PAMI is a fee-for-service organization, meaning that the clients pay us to conduct projects for or with them. However, some of our clients who are considered to be SMEs, small and medium enterprises, may be able to receive financial support through IRAP grants or other government programs. PAMI is well known by most of these grant providers, and our project costs are typically deemed to be eligible for grants requiring an R&D investment. If you have an innovation you want to work on, but need external funding in order to drive it forward, talk to PAMI and agencies like NRC IRAP about options. And lastly, before we turn it over to Ian, a reminder, PAMI does not retain IP. PAMI is here to help clients succeed. If we work on a project for or with you, any IP that results from our work will belong to you, the client. We can even produce drawings and documentation on your templates or in your formats if that's helpful. Raw data and CAD files, etc., can be yours if you want them and can use them. We regularly sign non-disclosure agreements with clients and can offer higher levels of confidentiality on projects if your project involves IP that's sensitive in nature that cannot become public. This is part of the reason we've been around for 46 years, but yet some people still wonder what we do. And here's my contact card. This presentation is being recorded and will be made available, so anyone who would like to contact me can feel free to reach out at those numbers. And at this time, I'm going to hand it over to Ian Paulson, who will introduce himself and present his slides.
Great, thanks, Larry. I assume everyone can see a mechanical engineering slide up on Teams here. As Larry said, my name is Ian Paulson. I'm our technical services lead in our mechanical engineering and simulation group. I work out of Humboldt as well. I'm typically in Saskatoon, but Humboldt's home base for PAMI here. So for most of my 10-year career, I've been involved in sort of various aspects of R&D for mechanical engineering projects, but with a focus in numerical modeling and simulation. In general, at PAMI, we work on a wide variety of mechanical and design and testing projects, as Larry touched on, but typically many of our projects involve an element of machine design for industrial machinery or mobile equipment. As well, we work in fluid mechanics and hydraulics and fluid power systems areas. And finally, we provided many solutions for material handling challenges, as those are definitely commonplace in ag and mining. I think one kind of unique thing about PAMI is our integrated design, testing, and prototype fabrication capability all within one organization. So what this means is it really supports fast design iterations of sometimes really different looking or really innovative solutions that we want to try out, as well as the ability to incorporate manufacturing feedback early and throughout our design process. Another key area for PAMI is our digital prototyping capacity through numerical modeling and simulation, and I'll be focusing on that a bit more in my slides here today. So here at PAMI, we run sort of 3 core simulation areas. I'd say we do a lot of structural analysis and motion analysis with finite element and multi-body dynamics. We use HyperWorks from Altair for that work. We also do a lot of granular material simulation using the discrete element method, or DEM. And we use EDM software, which is actually now owned by Altair. So there's lots of close coupling and capability within that larger package now. As well, for fluid simulations work using computational fluid dynamics, we use Star CCM from Siemens PLM. And these circles are overlapping here because we're seeing, I think, a growing interest from industry in solutions and questions that require co-simulation. So we're running multiple softwares at the same time to be able to simulate maybe airflow and particles or droplets, or material handling along with a finite element solution at the same time, or even soil and vehicle dynamics for mobility simulations. So for me, simulation is really about investigating design options early and failing on screen where it's cheapest. So it really allows us, it's a tool for us to be able to look deeper into a design early on, or maybe consider multiple design alternatives early in the process rather than having to throw options out early, and then understand where the weak points are, where we need to improve them, and how we can de-risk that final solution that gets implemented in service. So today I'll be talking over a couple case studies that look at de-risking design changes to in-service equipment in particular. That's often the case in mining, as well as understanding equipment performance in sometimes quite challenging environments and what we can simulate there. So the first case study that I'll look at here is looking at material flow, and material flow issues and wear are certainly commonplace in agriculture. And so it was really a natural evolution for, I think, PAMI to be looking at this kind of work in mining as well. So this is a 90-degree transfer point that a client had in service that had a lot of historical dust generation issues. So we can see here in the DEM simulation, particles entering, the coloring is based on material velocity. So we can see, acceleration and material stopping and then re-entering. And I'll get into the sort of design improvements in a minute here, but we started with the baseline design, even though we knew it had issues, but to get a deeper understanding of the problem that was there, and so that we can have a lot greater confidence in the solutions that we propose. So when we're looking at dust, what we want to be avoiding is, for a transfer point, is things like sharp velocity gradients, so suddenly stopping material, impacting material on the structure around it, and then having changes in flow dilation, we call it, or having it open up. And certainly some issues with this current design here shown. But again, if we can understand where we're starting from, we have a lot higher confidence in solutions down the road. Now, material handling isn't just about material flow. We also want to understand the impact, literally sometimes the impact on a structure, but how the structure is affected, particularly in terms of wear for a long service life component like a chute. And so we're able to simulate and measure, even just in relative terms, wear in DEM simulations as well. So same chute, we've just clipped the particles as they enter here and they kind of reappear at the bottom. And the coloring that we're looking at in this simulation is a wear metric that's contained right within EDM. So we can look at this sort of as part of the whole modeling process. And this was really interesting because this particular hotspot that was a concern in the simulation agreed really closely with the anecdotal comments from the maintenance team at site as to where they're constantly welding in repair patches. So it's always good to have that confidence gain and check that correlation box early in the process. So after getting a good understanding of the baseline problem, it's as Larry said, very much a collaborative design process with our clients often, and we want to leverage their expertise and be an addition to their team. So several design iterations later, we came up with a few concepts, one of them being shown here, and we can see a lot less disruption to flow. The other nice thing with EDM in particular, it's quite a high-end DEM package, and we can do a lot of different things in terms of material modeling. So here we can inject more and more larger particles to look at plugging, changes in material properties if we've got, say, a wet cohesive material or something like that evolves through a process. This was a kind of a fun project, and we ended up doing an inline chute instead of the 90-degree after this. And at that client, originally that inline transfer point, they had a lot of maintenance concerns, as they were having to muck out transfer points quite regularly. And after several months now of operation with this improved design, they really haven't had to maintain those transfer points at all. So even though we're predicting, relative improvements often in simulation, it's great to see that correlation, and that's what we're going for, those client wins in the end. So as well, another example, just looking at material flow within transfer piping. This is more on the processing side or maybe in a mill, but again, we can investigate early on what the flow characteristics are, and if we're looking at maybe a brownfield change at an existing site, whether we're adding instrumentation or a sampling port or having to do a piping change, right? We can know early on, are we getting the intended result? Are we but also, are we introducing potential issues that are maybe hard to see just in sort of an analytical analysis approach? So, plugging and spills, but also wear concerns. And so this is another wear prediction on the right. So there's actually two hot spots, one sort of at the top that's a little bit harder to see and maybe a bit less expected, and then more concern at the bottom. But again, these are things we can find out up front. The other interesting thing with bulk material is we're not just necessarily looking at flow path or velocity or bulk plugging concerns, but for a lot of process issues, we're looking at more subtle performance like material size segregation. So if we're doing sampling or looking at a material that has multiple ingredients and we're concerned about concentration difference, or maybe we have to do a material split and we want to preserve those attributes, we want to know if we're creating issues with the design in advance. And so this is just a simple example of a two-component material. We've got the red kind of larger spheres that's shown in the inset, and then many more particles of the smaller blue size. And same pipe as before, so we're dropping material in at the top, and this is sort of looking over top of the pipe. And as we'd expect, as we see in operational settings, we tend to get the larger particles floating up to the top, and conversely fines sort of settling out to the bottom if we were to look at the bottom of the pipe. And that's what we want to be able to predict early on to know if we're creating, if we have processes that are sensitive to, like I said, particle size or ingredient concentration. We want to be able to capture that, and we can with EDM. I'll change gears a little bit, looking more at finite element analysis. We're doing a lot of structural testing, particularly at our site in Portage with the equipment that they have there. And obviously, if we can avoid test failures and speed up the design process, FEA is the tool to use there. So we're involved with a lot of large deformation and plastic deformation analysis. On the left, well, these pictures are a grill guard on a semi. So you can imagine it's quite a dynamic event when we do strike something. We call them cow catchers for a reason, I guess. But in this test, we had quite good correlation. We did the FEA, and then after verified the solution within about 1% on displacement, and that's what we're certainly aiming for if we're trying to make absolute predictions with FEA. As well, fatigue is certainly a concern in mining and heavy equipment. And in this example, it's a jointed rollout rig matting basically that can be rolled up, but the client was looking at increasing the weight of equipment running over it and had concerns about fatigue and service life length accordingly. And so we started off with a bunch of physical testing. We actually strain gauged one of those panels, had quite a dense array of gauges on there to be able to, again, just get a deeper understanding of the problem and get a correlation data set for, in this case, multiple soils and multiple loading conditions. And it helped to understand the modeling problem better, but it also gave us a lot of confidence in the fatigue predictions that we had in the later FEA solutions. So that was evaluating equipment, but also we want to understand often environment with heavy equipment. And I'm going to borrow from some of our active ag research that we're doing here. So this is simulations of airflow patterns around high clearance sprayers. And so this is most of a 120-foot wide sprayer in a digital wind tunnel. And we're interested in the environment around that machine and what operational influences or operational choices affect airflow patterns. So do we have flow acceleration or deceleration in the blue? Are we creating large wakes that in spraying applications pick up droplets and sort of wreak havoc in that regard? And I think there's a lot of opportunity to extend this type of work to thermal management in a sort of an environment setting, or looking at airflow related to dust management, or even supporting computer vision field clarity requirements for automation efforts. So that's understanding some of the environment. We can then extend that to what is that doing on a particular process. So this is a sprayer nozzle, just a typical flat fan sprayer nozzle that you'd see on a high clearance machine. And partway through this simulation, we're introducing a cross flow, a wind from the right to the left. So that's a side view on top, and then sort of a view from somewhat behind that nozzle as we introduce that airflow. And the coloring here is droplet size, so we can look at, you know, very detailed metrics and measures in a simulation to understand what aspects of a given process or application approach, or, you know, whatever the problem is, but we can really dive in to see, okay, this is, in this case, the class of droplet diameters that we're concerned about for drift, or, you know, this is regions of heat of equipment that we're trying to cool that are going to suffer in a heat management scenario. And we've been able to extend sort of that coupled simulation work to some transfer point investigations as well. So this is a DEM solution for the ore flow, as well as moving conveyor surfaces and pulley surfaces here. So this was some initial work looking at what's the effect of movement of muck and of the belt motion on the airflow patterns around a transfer point, and how does that affect things that are you know, prone to cause dust, additional dust generation. So we can really get an understanding, you know, in a design situation or in an operation situation, of what are the sensitivities of airflow or turbulence, you know, things that we want to avoid potentially on given features of the ore flow itself, or operating conditions that we start to have a choice in. You know, with the eventual extension to something like design improvements, or like I said, operational changes in operation to reduce fugitive dust emissions. So with that, I'll conclude on sharing some of the examples that we've been able to complete here at PAMI that relate to mining. I want to thank everybody again for joining us today for the Lunch and Learn, and I'll turn it back to Larry for some final comments.
Okay, thanks, Ian. So I'll leave you with one more testimonial from another client that we have here. This is actually a photo of our 20% grade that we use to perform the CSA brake test that's called out in the mine regulations. That any vehicle that carries people, I guess, has to have brakes on it that are able to stop while traveling down a 20% grade. And we've got the ability to do that here out in the country, not far from Humboldt. Okay, so that concludes our presentation. On behalf of PAMI, I'd like to thank SIMSA for organizing this event, and thank all of you for spending your lunch break with us. I hope it's given you some insight into PAMI, and I'd welcome any questions you may have. And with that, I'll turn it back to Eric.
Well, thank you, Larry. And how these things work is typically we call for questions, and then there's this little delay here. So I have a little filler thing. First of all, these lunch and learns have been great. I've been learning a lot. I've like things I've never would have participated in before. I get to see and witness, and I'm going to circle back to the very beginning of your presentation when you talked about how ag and industry overlay, and I don't think people maybe realize that this has been going on for well over 100 years. If you go back to Henry Ford designing the car factory, like how did he do that? Like how does he the production line? At that time he went, well, how do I do that? How do I get to turn this into that, right? He went to the Chicago pork manufacturers is what he did. He went to Chicago, went there and said, how do you go from oink to bacon that fast, right? And so he saw they had this thing, that pig came in, it was hanging upside down, and each person did one little cut on the pig, and eventually it became, you know, pork chops at the end of the road there. So he flips it around and says, well, okay, we'll just do it instead of a disassembly line, we'll have an assembly line. We'll start with this frame, we'll just have one person add a piece on, and it'll go on the ground in front of you rather than hanging from the ceiling, we're done. And so there's this transition of you know, ag to industry that's been happening for decades, and it's great to see PAMI continuing on that tradition, at least without the death of pigs, though. Anyway, this is great to see. So, folks, if you got questions, please type them into the chat section there. There's a chat there, or we got a smaller group. If you want, you know, open up your microphone, maybe say who you are so we know who we're talking to. go ahead and ask some questions. And it's great to see PAMI does a lot of testing. You know, you also, I've seen the large fridge piece. Whoops, here we go. There. Has PAMI performed materials testing, such as abrasion resistance, strength testing, etc.? And somebody needs to unmute. There we go.
Yeah, I can address that. I guess yes and no. We typically are doing things that nobody else can do. So when it comes to like ASTM testing and standard tests like that, there are labs all over the place that have the equipment to do those tests, probably, you know, more efficiently and economically than us, because they specialize in that. So we don't typically do a lot of, you know, I guess what you would call, like, let's say you have a material that you need to know what the chemical composition is or do a tensile test on it. That's not what we do here. Yeah, so I guess, I hope that answers your question. I guess we're more into the, I guess, you know, finding out why you would need that, and maybe if you need that, helping you get that testing as part of, you know, a bigger project that that we're participating in. So we're a little more hands-on here, I guess, and not so much lab-based, if that explains it.
Well, thank you, Larry. I think that catches it. Graham, if you have any follow-up, please feel free to type it in or add it in. And we'll just wait for some more questions. And I noticed you made it pretty clear that in your earlier slides that PAMI does not retain any IP, and you know the work you do, it gets turned over to our members. I know that's always a bit of a concern. Let's put it that way. Anyway, one thing I was going to get to is the you know, the hot and cold testing ability. I've seen the you know, you've got a refrigerator big enough to put a tractor inside it, frankly, and or a deep freeze actually, and you can, you know, test things under, you know, harsh conditions without having to do it outside, which is kind of nice. So it's
Yep.
wonderful to see those abilities. Any more questions, folks? Any other? Is there any other areas of, you know, you didn't touch on today, Larry or Ian or?
I'm just going to zip back here to a slide because I think I might have forgot to highlight something. I did a dry run of this with our own staff on Wednesday, and I kind of got hammered for omitting this, and I have a feeling I forgot to fix it. So give me a second here. I'm going back to another slide.
And while you're doing that, another question came in. This is great presentation, PAMI team. Oh, there we go. Do you work with software development for control systems for equipment?
We certainly do, I would
yeah.
say.
Yeah, go ahead, Ian.
Yeah, I mean, we've done everything from supporting HMI development to shaking out bugs for implementations that are on machine already. So it's quite a wide array. I wouldn't say we're hardcore developers, but certainly the applied end of it, Jim, is where we're at. So.
Yeah, and I guess just on that, we have a lot of experience with like tapping into the CAN bus of different pieces of machinery. Some of you may or may not know that we spent a little bit of time, you know, 5 or 10 years ago doing a lot of projects for the Department of National Defense on some of their equipment that they were having some issues with. They needed some upgrades and some maintenance and things to it, and we were fortunate enough to be able to help them with some of that. And a lot of that involved, you know, tapping into the vehicle's, you know, CAN bus systems and adding new functionality or finding a way to accomplish something that you know, they were having difficulty with. So yeah, we certainly do. So what I wanted to highlight that I think I may have forgot to mention. So on the operation side, yes, we've got the electronics, automation and controls. We've got like mechanical and agricultural engineers and technologists and the agricultural services. But I forgot to mention that we also have an actual physical shop here that we can build things. We were fortunate when PAMI was created in the 70s to test agricultural equipment. We were fortunate that they had the foresight to also build us a shop so that when that equipment broke down, not if, when that equipment broke down, we were self-sufficient and could repair it. And we've used that shop to build prototypes and you know, do everything. So we're really everything under one roof type of company here. We can not only, you know, design things, we can also build it, you know, right outside of our offices and test it right outside of our offices. We don't have to, you know, send things across town or across the country to get things built and tested. We do it all in-house here at both Humboldt and Portage la Prairie.
Now I got 2 more things here. So first of all, on your screen there's a lady there. Her name is Leah Olson. I don't know if people may not, I should probably introduce her. She's the CEO of PAMI. She's kind of hanging out here in the weeds, and you're probably, who is this lady? Anyway, there's Leah. Hi, Leah. And Jim wrote, we will be following up, and great to see a service like this in the province. So good to see. Do you guys do wiring harness work?
Yeah, of course. We're actually building some harnesses right now for a client. We're not really set up to be a production facility. It's it's another one of our tools in our toolbox. We can do the design work, and we're fortunate that we have a cable shop here that we can, build the harnesses ourselves, and like you say, prove that they work and improve them if they don't work, and things like that. So yes, we do build harnesses here.
Yeah, when I was on a tour of your facility pre-COVID, which is now, I don't know, it seems like decades ago. I remember I was in your shop there, and they were building these wiring harnesses, and it was just like they were massive. So yeah, don't be afraid to tap them on the shoulder when you need to rewire something in a vehicle. Is there any other question, folks? Before we turn these, I come to the point now. Usually I go, well, we're going to sign off and done, and then some more questions come in. So let's just pretend we're going to sign off and be done now, please. Send in some more questions or any comments. We'll get on them right away here, folks.
Eric, if I can, I'll just add. So again, as Eric said, I'm the president and CEO, and I came on in April of last year, and just there was a question about have we done performance materials testing? What sort of work do we do moving forward? The reason why on the strategic plan we decided that we would go after 3 industries, one of which is mining, is because we had done quite a bit of work in that in mining. So many of you, I'm sure, I'm hoping that PAMI is not new to you, that you're aware of who we are. I can see Al is on and says thanks. So hi Al, we appreciate being able to work with IMII. But the reason for the really honing in on the skills that we have and the capital assets that we have is that when we think about the future, we want to be able to use the skills from each of the different industries, and where appropriate, transfer and use best practices, so that we're not always operating in a isolated way. So, when you do work with our organization, and Ian has worked, has a large breadth of industries that he's worked in, you get that as a bonus to your engineering team or whoever else that is wanting to tap into us. So, that was the rationale for going into the 3 industries, was that the skills were quite transferable. And when we think about automation, if it's getting the automated vehicles, mining is very much at the forefront on that. So to be honest, looking at automation and what can agriculture learn from the mining industry, there's some real good things that go together on that. But as Ian highlighted, when it comes to material flow, there's also some real synergies there. So that's what we're trying to do, is just work with the greatness in each of those industries. Thanks, Eric.
Oh, you're very welcome. Thank you for being here today. Thank you for holding the Lunch and Learn event today. Like I said, I've been learning a lot at these events, and I'm just kind of enjoying watching them as they go by. So folks, if there's no more questions, I think we can call it a day. Is there any more comments though from Ian or Larry or Leah before we send everybody off back to their reloading their coffee cups at lunch here?
All good on my end. Just want to thank everybody for their time again, and like I said, we've sort of done it all a little bit in some way. And if people have more questions, don't hesitate to reach out to Larry or I or Leah or anybody in the organization to say, hey, have you done this or that? That's often, I think, where a lot of the ideas, the good stuff comes out. So just want to thank everyone again.
Well, thank you. Well, thank you, folks. It's been a great event again, and wonderful to see everybody, and nice comments coming in on the chat section there. So have a great day. Stay safe this weekend. It's supposed to be a warm Sunday afternoon when the Riders win their football game. It's not if, it's when. And then we'll get off to take care of those peggers and Tobins out there, that smell that comes from the west, the east of us, I guess, flowing west. So anyway, thank you, folks. Have a great weekend.